This is a problem from chapter 21 Coulomb's law of Resnick Halliday physics, 10th edition. The problem is that figure 21.30a shows an arrangement of three charged particles separated by distance d. Particles A and C are fixed on the x-axis. So this particle A and this particle C, they are fixed on the x-axis, but particle B can be moved along a circle centered on particle A. So this particle B can go around particle A in a circle. During the movement, the radial line between A and B makes an angle of theta. So they are just showing one of the intermediate positions. So this angle is theta. The curves in figure 21.30c give for two situations the magnitude F of the net electrostatic force on the particle A. So this is F net. Okay, so this is the total force on particle A due to the particle B and particle C. The net force is given as a function of angle theta and as a multiple of basic amount F naught. For example, on curve 1 at theta is equal to 180 degree, we can see that F net is actually equal to 2 times F naught. So this scale here is marked in terms of F naught. So you can say that this is 1 F naught, this is 2 F naught, so this is 1.25 F naught, 1.5 F naught, 1.75 F naught, and so on. For the situation corresponding to curve 1, what is the ratio of the charge of particle C to that of particle B, including sign? So we have to find what is the ratio QC. Let us say that this charge is QC. Okay, so we will say that this charge particle has a charge QC and this is QB and this is QA. So this is the charge that they have. So we have to find the ratio QC is to QB. For the situation 2, for the situation corresponding to curve 2, what is that ratio? So we have to find the QC is to QB for situation A and situation B. Now for this problem, we can actually assume that particle A is positive charge. Okay, we are assuming that particle A is positive. It does not matter whether you choose that particle A as positive or negative, because what we have to do is we have to simply find the ratio of QC is to QB. So you can assume particle A as positive, or you can assume it as particle A as negative. The only thing is that the sign, that the direction of the forces will change. Okay, so we are assuming that particle A is positive, and based on that assumption we are going to find out what are the forces on particle A due to particle B and particle C. So let us first find out what is FAB. Okay, what I want to find out is what is the force on particle A due to particle B. We know that this is going to be K times QA times QB divided by the distance square, which is d square. Okay, and we are only talking about the magnitude here. Okay, then what is force on particle A due to particle C? That is going to be simply K times QA QC divided by the distance between them is 2d, so it is 2d square or 4 times d square. Right, now let us check what happens at, so we are right now considering only the curve 1. Okay, this solid curve is curve 1. We see that at 0 degrees there is no force acting on particle A. Okay, at 0 degrees there is 0 force. So what it means is that the force on particle A due to particle B is in the opposite direction of the force on A due to particle C. Right, so how can this happen if A is positive charge? This can happen only if B and C are oppositely charged. If B is positive charge and A is positive charge, then the force FAB will be in this direction, right, towards the left. If A and B both are positive charge, then force FAB will be towards the left, and if C is negative charge, then this will be towards the right, and these forces can balance out if the charges are of right amount to be 0, right. So let us see how can we solve it. So now let us say that we are taking that the positive x direction is the right. If we go towards the x axis towards the right, we will take that as positive. So we know that at theta is equal to 0, the force is 0. So we know that net force on particle A is k times qa times qb divided by d square plus k times qa qc by 4d square. We know that this is 0. Okay, so the net force is 0. It means that I can take out k qa d square as a common factor out. So this implies that k times qa d square times qb plus qc by 4 should be equal to 0, and this will give us qb plus qc by 4 is equal to 0, and therefore qc divided by qb should be equal to minus 4, right, and it seems reasonable. Why minus 4? We know that C and A have to be of opposite sign. So if B is positive, C has to be negatively charged. If B is negative, then C has to be positively charged. So that is why we have a ratio of negative number, and QC, that is charge QC, particle C should be 4 times the charge of B because it is farther away. So the force of particle C on particle A would be lesser in magnitude, and so if at theta is equal to 0 degree, if it has to balance out the force of particle B, it should be larger than B, and that is why we get QC is to QB as minus 4. Now let us look what happens in the curve of situation number 2. Okay, so again we can look at theta is equal to 0. At theta is equal to 0, it is 1.25 f naught. Okay, so remember that this value over here is 1.25 f naught. And what about this value over here? This is 0.75 f naught, right? This is 0.75 f naught. So we know that at theta is equal to 0 degree, the force acting on this particle is, we have already found out before, it was simply k times qa over d square times qb plus qc over 4, which is this term over here, but this time it is not equal to 0, it is equal to 1.25 f naught. Now at theta is equal to, so this is theta is equal to 0, this is theta is equal to 0, at theta is equal to 180 degrees, what happens? Particle B comes to the other side of particle A, and whatever its direction of force was at theta is equal to 0 degree, now the force will be in the opposite direction. So we can write that at theta is equal to 180 degree, the force would be simply K times QA over D square times minus QB, because now B is on the other end, plus QC over 4. And what is this value equal to? This value is actually equal to this value is actually equal to 0.75, okay, 0.75 F naught. So it is 0.75 F naught, and from these two equations we can again solve what is QC is to QB. So let us move to next page to solve this one. So we can divide those two equations, right? We can divide equation B, we can divide this equation by this equation, okay? So if you divide it, you will get QB, you will get QB plus QC by 4 divided by QC by 4 minus QB is equal to 1.25 by 0.75. So this should be 5:3, right? And this means that this is 4 QB plus QC divided by QC minus 4 QB is equal to 5:3, and we can get 4 plus QC divided by QB. This is what we have to find. QC over QB minus 4 is equal to 5:3. So QC is to QB is the ratio that we have to find. Let us say that value is equal to R. So we are saying that 4 plus R over R minus 4 is equal to 5:3. So 12 plus 3R is equal to 5R minus 20, and you get 2R is equal to 32 and R is equal to 16. So in this case QC is to QB is 16. Okay, so now in this case the sign of both particle C and particle B is same, and charge QC is actually 16 times the value of charge QB. And we are done with this problem. I hope you understood